Hangileri? İlk defa o epey gelen var, harika. Tanıtma şansı bulacağız kendimizi. Ben Altu Altıntaş. Neler yapıyoruz? Böyle fotoğraflarımız var. Bu geçen sene miydi Taner? Neydi? Greenfield projesinden bir sahnemiz var. Bu da burada yapmıştık. Code Retreat ki bu hafta sonu var. Yine ama hızlı dolmuş bir sene. Hızlı geçmiş yani. Workshoplar yapıyoruz, meetuplar yapıyoruz, Java Day yapıyoruz, Java Day İstanbul, böyle bir gönüllü şeyimiz var. Lütfen katılın, katkı verebiliyorsanız gelin. İşte herhangi bir şey anlatabilirsiniz. Kevin geldi daha Almanyalardan. Dedik okey, harika, süper. Kevin anlamıyorum, kötü bir şey söylemiyorum.
Tamam,
okay.
Tamam.
Bu sene Java Day İstanbul Mart ayında gerçekleşecek. Mart'ın 16'sında, 15-16, 2 gün. O yüzden onu da haber vermek istedim. Eğer call for paper'larınız varsa başvurun lütfen, konuşma yapmak isteyenler. Kapanacak ama az kaldı lütfen. Elinizi çabuk tutun. Gibi ekibimiz. Daha da gerisi var ama aktif olanlar, sizler de burada yer alabilirsiniz. Hüseyin Hocam en havalısı galiba. Okey. Şimdi biraz önümüzdeki şeylerden bu, evet. Bugün Integration Testing with Docker and Testcontainers'dan Kevin anlatacak. Okey. Bu cumartesi günü de arkadaşlar şeyimiz var. Yine Meetup'tan görebilirsiniz diyeceğim ama görebilir miyiz? Neyse şeyimiz var. Code Retreat var, söyleyemedim. Şurada Meetup. Nerede olacak? Şurada. Global Day of Code Retreat. Deloitte'un yerinde. Maslak'ta. Cumartesi günü kaçta başlıyor Taner? 10 mu? 10'da başlıyor. Katılmak isteyenler, ustalık kazanmak isteyenler için duyurulur. Onun dışında söyleyeceğim bir şey var. Java Day'den bahsettim. Okey, onun dışında zaten az kişiyiz. SiliConf yapmıştık ama kullanmaya gerek yok. Yani soru sormak isteyenler olursa yine ben böyle söyleyeyim, bunu Java Day'de de kullanıyoruz. Bu uygulamayı, kodu bu. Hani orada Kevin anlatırken soru sormak isterseniz cep telefonundan oylayıp hani en iyi soruları, işi bittiğinde, yani konuşma bittiğinde en iyi 3 soruyu Kevin'a burada çıkıp sorabiliriz. Bu da hani böyle mikrofon alıp soru sormak biraz sıkıntı yaratır ya, böyle bir stres olmamak için bu uygulama var. SiliConf diye geçiyor. Kodumuz LKQ ne? Şuraya yazabilirim. Efendim? Sorabilir miyiz? Uygulama kullanmadan. Efendim? Sorun ama yani olurken İngilizce falan böyle daha kafanız... Evet, SiliConf da var. Yani az kişiyiz, çok kalabalık olacağını düşünmedik ama yine açtık böyle. Okey, sorularınız var mı? Java User grupla ilgili, etkinliklerle ilgili var mı efendim? Geri bildirim var mı? Kötü yaptığımız şeyler, iyi yaptığımız şeyler var mı? Ona da aralarda konuşuruz zaten. Teşekkür ediyorum. Kevin, okey.
Right. Nice. Yeah, thanks. Okay, cool. Yes, thanks for the nice introduction, I assume. I didn't understand everything. Regarding the Global Day of Code Retreat, I can very much recommend this. So we are doing the same event like in my hometown with a software craftsmanship meetup there. And if I wouldn't celebrate the birthday of Nestle, my girlfriend, on this day, I would also join here at the Java user group. So very much recommended. And yeah, I'm very happy to be here today and talk about integration testing with Docker and Testcontainers. Since like a lot of the international speakers always do a speaker selfie at the beginning of the talk, is it okay if I take one? Yeah? Sure? Okay, cool. So, yeah, then I also feel like an international speaker. All right, thanks. 1, 2, 3, go. All right, cool. Okay. So yes, and by the way, really great Java user group logo. So the Duke with a traditional Turkish hat looks awesome. Now, I heard it's not a traditional Turkish hat; it's an Ottoman hat. So, but still awesome. All right. Some words about me in the beginning. My name is Kevin Wittek. I'm technical lead at Jdata Advanced Analytics in Germany, Bochum. It's a cybersecurity company, and I'm also a consultant, and it's written wrong here, I see. In my own company, Styracosoft, there I'm doing coachings and workshops to topics like software craftsmanship, clean code testing, and so on. Recently, I've also become a trainer for another German consulting company, B42, where I do like Java and container workshops, trainings, whatsoever. But more importantly, I'm one of the test containers maintainer, and yeah, big open source fan enthusiast, so to say. And so because of this, I hope I'm like well equipped to talk to you about test containers here. And yeah, since recently I'm Oracle Developer Champion, Groundbreaker Ambassador, whatever this means, I'm also not sure. And I organize a local software craftsmanship meetup in my hometown area. So yeah, before we start, we recently watched Jurassic World 2, which was, I think, quite a cool movie. And there was a nice scene, and I hope I don't spoil too much here. But what they did was they captured the T-Rex from the island and transported it somewhere else. And for this, what happened, basically, they put the T-Rex in a container. So, and this was, for me, like a really nice image, something motivating when you're working with containers to see like they can put a T-Rex, a dinosaur in a container. Then we also can put things like an Java application server or Oracle database in a container, I assume. So what I want you to take away from this session, like that nowadays it's quite easily possible to set up a complete test and development environment on your system described as code. And this, on the other hand, means that nowadays we don't need a lot of effort to write integration tests against real external applications. So we might get away from all this mocking, stubbing stuff, at least for some use cases. And I will talk a lot about test containers, but I will also talk a bit about the Docker Spock extension, which was kind of a precursor to some of the test container stuff, and we will see in some of the design mistakes that have been done in this extension what you have to keep in mind when you're working with containers, basically, yeah. And so this small bash snippet here, shell snippet at the bottom is what I think onboarding in a new project should look like, either in an open source project or in a business, in an enterprise. If you come into a new team, you should be able to simply check out your repository and build it. And then it should like build the application, run all the unit tests, run all the integration tests, maybe acceptance tests, whatever, without you having to do anything manually before. So that's like, I want to show you that this is possible, kind of. So before we go more into the technical details, let's talk some semantics before, some theory stuff. Like you probably all know this classic testing pyramid from university, from books, whatever. And how is it structured? So we have this big foundation of unit tests, and then we have this middle layer, which are less, and which are integration tests. But sometimes we are giving it a different name. Some people call it component tests, some call it system test, API test, whatever. Some make distinctions, like in this example, it says, oh, integration test is something more complex than a component test. But for the sake of simplicity, let's say the middle layer here is integration test. Then on top of it, we have automated UI testing or graphical user interface testing. Some might call this functional testing or acceptance testing also. And like, for example, what you would do is a Selenium test maybe. And at the top, we have, in an ideal testing pyramid world, we have some manual explorative session-based testing. This is the stuff that the testers, the quality assurance people would do, but based on all the automation here. Yeah. So for like the talk today, how would I define integration tests so that we all have the same understanding of integration test? For me, it's every test that interacts with an external system or dependency. What does it mean? For example, when we launch an application server from a test, or like in the case of Spring, if we instantiate the Spring context. Also, if we would interact with external frameworks or libraries, again, Spring is a good example here. This is an integration test since we integrate against this framework. And then the classical example, if we're thinking about like a hexagonal architecture and we have all our outside ports, so components that interact with the network or the file system or the database. Like this are, of course, the classical integration test examples. Some people might have different definitions, like saying integration tests are the tests that run slow or whatever, but let's just take this as integration test. So all the stuff is kind of suited towards monolithic applications, also the theories behind it. Now we are going more and more into a microservice world, kind of microservice architecture. And what happens if we go into the microservice world? I found this nice diagram in a blog post from Martin Fowler. We don't look into detail. I just want to show that, like, Martin Fowler, which we could maybe consider like a good software engineer, or at least he has some knowledge about this kind of stuff, he shows a different organizational structure for integration tests for microservices. So I don't want to look here in detail. I just want to give you a hint that maybe we have to rethink our classical testing pyramid for new architectures like microservices. So what I want to talk about is this thing. It's called the Testing Honeycomb. And it appeared beginning of this year in a blog post from Spotify. And Spotify, they have a microservice architecture, and they wrote about how they test their microservices. And they said, we are not using the classical testing pyramid. Our tests are more aligned with a honeycomb like this, or you could say maybe something like a diamond shape. So you have some implementation detail at the bottom. This is what we would call unit test in the testing pyramid. Then you have a big block of integration tests, and then you have some integrated tests. And this was the first time I heard the term integrated tests. Who here heard the term integrated tests before? Yeah, cool. Would you like to explain what it is, or like give a small definition? No, okay. Then I will go on. So I then looked it up, or looked up what the blog post linked to, what is an integrated test. And the Spotify article linked to an article by J.B. Reinsberger. He's kind of known in the software craftsmanship, TDD community. And he says, so integrated tests are an anti-pattern. We don't want them. And he says, I use the term integrated test to mean any test whose result, pass or fail, depends on the correctness of the implementation of more than one piece of non-trivial behavior. And then Spotify condenses this definition to the sentence, a test that will pass or fail based on the correctness of another system. So something you don't want to have, because what are integrated tests? For example, if we would need to manually spin up other services in our local testing environment. For example, we need to have our database started locally, a Postgres database or whatever, so we can run the tests there, the integration tests there maybe. Or even if we are using already something like Docker, if we manually have to do a Docker compose up before the tests are run, this is kind of an integrated test. Another classic example is if we are using some shared resources somewhere. For example, a shared testing environment, or if we share a database, maybe even the same database schema, and then the one team might run some tests with database migrations, whatever, and therefore breaking the tests of the other team. Completely unrelated to what the team did actually change. And yeah, another example, if you change your system, you are breaking automatically another system. Also something we could imagine if we have this shared test environment where constantly the newest version of an application is deployed, and there you're running your integration test. You're updating your service, maybe doing an API breaking change, and then the test of the other team will fail. So we don't want to have this. And one way to avoid them, we will see, and Spotify describes this in their blog post as well, is using Docker and Testcontainers. Okay, genau. So, genau, exactly. So, which tools do we use now in the JVM world, and maybe beyond this? This is like just a set of tools or libraries I like. You can use other things, but I think they work well in conjunction. So Groovy in the middle there is just for fun, because I'm a Groovy fan. You can do everything I'm showing today with Java. I think some of my examples are in Java. So Groovy just for the sake of Groovy fun. Of course, Docker plays a big role, and like just our basic test frameworks could be something like JUnit, JUnit 4, JUnit 5. We have Spock there. We will see some stuff with Jab for Selenium testing. But then, of course, the maybe interesting part of the talk today is using Docker together with test containers. Yes, since I have some examples in Spock, I want to get a really quick introduction to Spock. Who here knows Spock? Ooh. So Spock is a test framework for the JVM, so like something like JUnit, but you're writing the tests in Groovy. But you can use Spock test to test your actual Java production code. So this is how a Spock test could look. Like we're seeing here, a couple of Spock features mixed together already. So at the one point, so you're creating a Spock test. They are normally called specifications, but it's just a test like JUnit test. You create it by extending a base class specification in this case, and then you're defining test methods, just like JUnit. Now we can see here def and then the string. This is nothing Spock specific. This is something from Groovy. So in Groovy you can use strings as method names. It's something you would normally not use in production code, but in tests like this, it's of course very convenient because you can describe what the test actually does very easily as a sentence in a string, instead of like going the way we would go in JUnit 4, for example, where we would have like maybe a long camel case method name or underscores or whatever. Yeah, so this is this, and we have these labels here. Like this is a label you also have in the Java language, but nobody uses it there because what would we use it for? But here it's like expect and where, and there are different ones like given, when, then, the classical BDD stuff, and in this case the expect block means that the expression inside this block is or every expression inside this block is automatically asserted as a Boolean value. So it's the same as if we would say assert this expression true. So it's like a bit syntactic sugar. You don't have to use something like assert j or whatever, Hemcrest. And also thanks to Groovy, if the assertion would fail, you would directly get a very nice exception like assert j, where it would split up like expected, actual, would show the difference in a string whatsoever. Very nice. And then we see one of the coolest features in the where block. It's called data-driven testing, and in this case, every line here is a new test parameter definition, so to say. So we are actually having 3 tests here defined. So every line in the table are input variables for the actual test execution. So it's like you would use a JUnit for parameterized test. Okay, so then next, Docker. Who here knows Docker? But not all. So I will dive a little bit into it. Not in detail, but a little bit into it. So first of all, so Docker is a container runtime, we can say like this in an easy way maybe. So you can use Docker to start container, manage containers, and so on. What is a container? So containers are user space processes that isolated user space processes that share the same kernel. So we can have running different containers on the same operating system, on the same kernel, and the one has like a classical Java stack inside with the Debian as a user space distribution at the bottom. Then we have another that is more like a Microsoft .NET stack, and then we have something like that doesn't have a lot of dependency. For beginners is that you can compare a container to a virtual machine, and like the metaphor is practically wrong, but is a nice way to understand how you could maybe see a container. So let's assume a container is basically like a virtual machine for the way we work with it, but now let's look what the actual difference is. A virtual machine is running on top of a hypervisor, and then it has the complete guest operating system inside this virtual machine. So we have a complete isolation of the kernel and the operating system there. In case of containers, they are all communicating with the same Docker daemon, which on the other hand communicates with the host operating system, the kernel, whatever. And this is something to keep in mind when you're considering like your isolation constraints or whatever you have. But of course you can mix and match basically the stuff. So you can run containers inside a virtual machine again. And so why do we want to use containers now? Because it's, instead of virtual machines for the use case we're describing, because it's much, much faster to spin up and spin down containers. And that allows faster integration tests in this case. Okay, so yes, why would we combine this whole container stuff, Docker, with our test framework? It allows us to very easily set up our development environment. In this case, I'm say a development environment because for me, running the tests locally is part of my normal development process. And this also means that I can have a uniform build and test environment. So the way I'm setting up my external dependencies, like database whatsoever, works the same way when I run it locally or when I run it like remotely on my CI server or whatever. So, and if the new person comes in, he can just check it out and it runs directly. And then we have ideally no dependencies to install external software on our developer workstations, except Docker, of course. So everyone who knows this experience, like coming in a new project and the people will say, oh yeah, for building the application, you just have to check these two wiki pages, but yeah, if you get stuck at one point, don't matter, they are like 5 years old and no one takes care of them again. So yeah, this is something we don't normally want as a nice onboarding experience. Because we want this as an onboarding experience. And how can we combine those two now? So we've seen Spocker as a test framework, we have Docker, and then we combine them, and then we get Spocker. And so what is Spocker, or what was Spocker? It was a test extension for the Spock framework. And we will look into this to learn from the mistakes what you have to keep in mind when you're want to instrument containers in your tests. So this was the way how it was first developed. So back then I was very heavily influenced by the Spring Boot testing framework, which was heavily depending on annotations. And I thought, okay, the best way to define my external dependencies would be to have an annotation, Docker annotation, and there I would say, okay, I want this container. And this was basically the public API back then. So you would define the image you want to use, and you would define which port you want to map, and then it would simply start it up before the test execution happened. Yeah, you could either annotate a class with it, then it would be there for the whole class, or you could annotate every method with it, then it would just be there for this test method. And the actual implementation wasn't a lot. Don't look at the actual Docker interfacing code, but just the extension code. It was simply, you get this callback here, intercept spec execution, and which is called before the test is executed. And so you do start container before the test is executed, and afterwards you do stop container. That's it basically. So what we can imagine that behind this Docker client start container, what's actually behind this is a Docker run command. And there's already basically a race condition hidden in there. So what would happen if you would imagine now that Docker start container just calls Docker run Postgres? What's the race condition here? Anyone knows?
Your application starts earlier than the Postgres container, basically?
Yeah, so it's, yeah, you're close. So the container starts directly and it started, but the application inside the container hasn't started yet. It's not available for interaction. So yeah, that's something you have to keep in mind. So it's not that trivial. So you need to wait until the actual dependencies are ready before your system can interact with them. So this was the first iteration, kind of first draft. But what happened then? Sergey, who is now working for Pivotal, for the Spring Reactive team, approached the Spocker project on GitHub, and he created an issue and said, oh, just listen, we are working on kind of the same use case. It's called test containers. We are already much farther than you are here, and we've already solved much of the problems you will run into. So why don't you port the Spock extension to test containers? And yeah, then I looked at it. So let's look at test containers. What's test containers? It's a Java library. One could say a JUnit library, but first of all, it's just a Java library. So what we can do here, now the approach is not annotation driven. What we can do is basically have an object-oriented abstraction of containers. So we can instantiate our container here, kind of similar, like you're setting an image here, you're setting like which port you want to use to interact with this container, and then you're calling start to start and stop to stop. So that's the API of test containers in this case. Yeah, it does more. So this is not like a simple Docker run in this case. So because what is behind it? Let's look a bit at the feature set of test containers roughly. So we have, as we've seen in the slide before, we have something called a generic container, which is just a generic container class which could contain any image. Like in this case, we have a Redis. You could put everything inside, your own images or whatever you can imagine. MongoDB, for example. But also test containers provide specialized container classes, Java classes. So you can directly instantiate a Postgres or whatever, a Selenium, a Kafka cluster, and this will provide you with some nice additional convenient methods to better interact with this container. We will see some of them in the example soon. You can also just say, okay, build a container based on this Docker file. You can define a Docker file as a DSL in Java, if you don't want to write Docker files for whatever reason. It has support for Docker Compose. You can also, we will see this also in an example. You can just say, okay, start this Docker Compose basically as wrapped in a container. And then the next feature is quite important, and this was very much lacking in the first example. So there's something like dynamic port binding and an API to access the dynamic port. So if we look here again with exposed port, this is not doing the same thing than the annotation did before, like basically mapping this port 6000 to some other port statically on your system. Instead, it's like if you would run docker run -p 6379 Redis. So you're not defining a static port binding. Why do you not want to define a static port binding?
There could be other applications using it.
Exactly. The moment you do this, you have again an integrated test, and you don't want it because it will be a pain in the ass for parallel testing. For CI environments probably, and yes, you don't know what other applications are actually running on your desktop maybe. So I think Skype used to block or use port 80 or port 8080 back then. I'm not sure if it's still true. So yeah, instead you're just saying, okay, I want to interact with this port, and then at runtime after the container started, you can get the actual port that's mapped to and injected into your test. We'll see this in the example. And next thing, super cool, wait strategies. That's what I said, what's happening when you call this container.start. It's not like a Docker run. Instead, it's like a Docker run and then blocking until the application inside the container has started. And what does it mean? You can define different wait strategies, like just is the TCP port reachable, has a certain log message been logged, or do you get a certain HTTP response? All kind of stuff are thinkable at this point. Yeah, we try to provide a complete and very good out-of-the-box Docker environment discovery. So it doesn't matter if it's running a normal Docker on Linux, Docker for Windows, Docker for Mac, or something like Docker Machine with a remote Docker engine. It works out of the box by discovering the environment. And also because of this, it's basically platform independent. So it works on Linux, Mac OS, and with the latest 2 versions, also very good on Windows 10 with named pipe support. Yeah, exactly. Works on Windows 2. I was too happy when we got this finally working with named pipes. Yeah. Oh, good question. Who here knows test containers? Some. Who here uses test containers? I hope after the talk more. So we don't have to go into the details of the new release. 1.9 was basically where we got out of the box Docker for Windows 10 support, which was very cool. And then now the new version, we have official JUnit 5 support. Who here uses JUnit 5? Ah, okay. Who here uses JUnit 4? What are the others using? Test NG? No tests? Who here doesn't write tests? Yeah. So, yeah, official JUnit 5 support from Benedikt Ritter, who is now working at Gradle. And also a special Elasticsearch container out of the box working for Elasticsearch. Cool. JDK 11 compatible with the latest release also. Here just a quick overview about the specialized containers we're already providing. All kinds of databases, Postgres, even Oracle works, MySQL, NoSQL databases like Influx or Elasticsearch now, of course. We are providing special browser containers which build in Selenium WebDriver stuff, and also more complex infrastructures like Kafka with embedded Zookeeper or whatever. And here we see some of the users. Of course, Gdata, we use it, but we're getting more and more high-profile users, kind of, and so we are very happy about it, and the community is growing there. So JetBrains is, for example, using it for testing TeamCity, and Spring, especially the Spring Data team, started to heavily use it for their internal testing of Spring Data, which is super cool.
So are we limited to those supplied to us, or we can implement our own container?
You can implement your own quite easily, actually, yeah. So for example, the generic container is already your own. You can put everything inside, and if you have something more specialized, you can still do it, but...
for example, we want to deploy a live application server. We can
yes?
check if it is live or not.
Mm-hmm. How would you check if the application is live?
If we deploy the application, we can have some HTTP response.
Yeah, super easy. You can already do it with generic container. Oh, yeah. Then you just say, we will look, I will try to come up with a code example, then we see how you would do it. So the first thing that happened after test containers has been integrated to the Spock extension. The Spock extension was still being based on annotations. Then it started to look like this. Because we tried to provide all the flexibility, all the power of test containers in annotations. And annotations are, of course, very limited. You basically only have basic data types in there and anonymous classes or anonymous functions. Yeah, it's super messy. And you can't have any logic in there. So it becomes super messy. And instead, what happened, the API, basically, of the test containers extension changed to embrace test containers more. Now is again a Spock test, and what we see here, we are also just defining a container as an instance of a field, of a test class. And then we have a test containers annotation at our test class, and this will just lead to the extension scanning the test class for container fields and then starting and stopping them accordingly. The @shared annotation here is a special Spock annotation, means this field is shared between all tests. In this case, this translates to this container is shared between all tests. And this is the out-of-the-box JUnit 4 integration you can use. You are just annotating the field with a JUnit rule. JUnit rules, for those of you who don't know it, there are rule and @class rule. @rule means it's evaluated between every test run, @class rule just for the test class once. And in the case of the test containers class rules or test containers JUnit rules here, it's just the same. It means starting, stopping between every test run. But you can, of course, always do the start, stop manually. So it's just two methods if you want to control the life cycle of the container yourself, like in the @before or wherever. And yeah, here, brand new, this is how test containers JUnit 5 extension looks, or integration looks. JUnit 5, of course, is actually called Jupyter. And it's kind of similar to the Spock integration. So you annotate the class with @test containers, and then you annotate the fields, which have to be containers you want to have managed by the extension with @container. Okay, and yes, finally, we can come to some real examples. So, all right. Or are there any questions so far? No? Okay. So if you want to integrate, if you want to use test containers, all you have to do is include a dependency, like in Maven or Gradle. We are providing a BOM, bill of materials. So for those of you who know this from the Maven world, it's now also supported in Gradle. And this just means that I can use the actual test containers modules I want to use, the Spock module and the Postgres module, without also defining the version number here. And let's look in, oh wait, no, this is not the first example. This is the first example, okay. But the build.gradle looks kind of similar, yeah. So we have some Java production code, and yeah, the application is as simple as it could be. So it's a classic bookstore application and not even this. So we have this entity here, a book entity, just two fields, name and author. And then we have a book repository. Since I wanted to have a very vanilla Java example, I didn't use anything like Spring Data or Hibernate here, like just plain Java JDBC stuff, basically. So what we see here, like a book repository where we have our methods like save, count, fetch, or search, whatsoever. And we don't have to look in the actual implementation in detail. But one thing here is kind of important. What I'm doing here is like I'm providing the JDBC URL I want the repository to interact with in the constructor. So it's like basically dependency injection, super simple case, just done manual and not by inversion of control container. And why do I want to do this? Because I will start the container and I don't know when I'm writing my tests, like at which port it will run. So I don't know the JDBC URL before the container is running. So I want to create the book repository with the JDBC URL pointing towards the running container. And this is the easiest strategy. Just make your components testable by having some kind of dependency injection, either in constructors or in methods. Then you can, for your tests, easily configure your system under test for your needs. So it would be the same if you would want to stub or mock something. And in Spring, it becomes more difficult. We will see how we can solve it there. And yeah, then we're just having here a connection and doing the SQL stuff. That's not the important stuff. And then we also have another class here, special offer notifier, whatever it would do, like maybe send out special offers to a Kafka topic. So what it can do is send records in a Kafka topic. This is also something we want to integration test. And here again, I'm kind of injecting the actual location of the Bootstrap servers. So that's the way I would create my Kafka producer. I'm injecting it in the constructor here. Let's first look at our book repository test. Spock specification here, Spock test. We see the class is annotated with @Testcontainers. We are defining here a special container, Postgres container in this case. So it will automatically know we will have like a Postgres image we want to use here. Then I'm just using Flyway for the initial schema creation. Like for those of you who don't know Flyway is just a Java library for database migration, kind of. And so here we see the first kind of syntactic feature of the Postgres container. We can directly obtain the JDBC URL of the running container here. And what is actually happening here is we're just concatenating the JDBC driver stuff here with the container IP address plus the map port that is mapped to the Postgres port. So this is something you would do if you would not use here, in this case, Postgres container. You would just have a generic container where you would put in your own database or whatever, and you want to build this JDBC URL. You would need to do this get the, always something like this, concatenate the container IP address with the actual map ports. This is our API here. And why do we need the container IP address, or what does it mean? One could assume container IP address means the IP of the container, but it's not this. It's the IP under which the container is reachable over its map port. So maybe the name get container IP address is not perfect here, but what it results in practice is that normally it would be something like localhost if you have your Docker daemon running on your machine, but it could also be the IP of a remote Docker daemon. Okay, so, and other getters here, like get username, get password. So we're doing this here for Flyway, and then we're doing the same thing here. So I would call it poor man's dependency injection, but it's actually not poor, it's just clever, like getting this stuff in there so we have an object that we have under control that works with the external resource we wanted to. And yeah, then we have here some easy tests, like initially the repository is empty. Then if we would save a book, there's one book in the repository. And if we would save multiple books, we can search for the author, like we have here two books from author Terry Pratchett and another one from Herman Melville. If we search for the books from Terry Pratchett, we would get two books, like the one we expect, where he's the author. So let's run the tests. It's actually not that spectacular, but let's just do it. Okay, we see here some log output already. We see this small Docker whale here, which might indicate that this is something Testcontainers is doing. We see some logs from Postgres, like starting container and so on. So yeah, this is being done here. And okay, this is kind of slow, one could say. It took 18 seconds. If we would do the same thing with an H2 in-memory database, it would probably take 18 milliseconds. I don't know. So you don't have to use this test pattern for everything. If you have something you can do better with an H2 in-memory database, use it, it's fine. But if you have maybe some vendor-specific SQL or whatever, and you want to have an integration test against the actual database you will use in production, and in case of Oracle, this is often very different than how an H2 might behave, this additional time overhead is something you might want to pay. And in this case also note that it's not annotated with at shared. This means we have created a new container, a new database between every test. So we've created a complete new Postgres database between every test. And I think, okay, for this 18 seconds, it's okay, I think, on a laptop. What would happen if I put add shared here? Maybe it would still work, but probably not. Let's just try. So now we will use the same database instance for all tests. Maybe it will still work because the tests don't really, yes. Yeah, of course. We don't have to restart it yet. No, but let's do the following. I add stepwise. Stepwise is a Spock annotation. It means the tests are run in the order they are defined. And I'm moving this method to here. So that means we are first testing that there is one book in there, and then it might still work because Flyway is dropping it. Then it would be also cool. No. Now it's failing. Yeah. So because now we are using the same database, we are not dropping a schema or whatever. It means when we save here one book, the database contains one book, and then the next test fails. So yeah, this is what we would expect, wouldn't it? So I want to show one more thing while the tests run. Yes. Like this. Okay. So what we see here is something interesting, and some first-time test containers users are kind of confused by this. We see the containers that are running during our test. First, Postgres. Okay, we expect this, but then we have another container running here, and if we look at the image name, it's test containers Ryuk, so it's probably something that has to do with test containers, and yes, indeed it has. It's a sidecar container. We are starting with test containers for doing the resource cleanup, basically. So what's happening is that test containers will start this Ryuk container first. It will then start the Postgres container. It will then register the Postgres container and say, like, OK, clean it up once the test has finished. And then once the test has finished, the JVM and test containers in the JVM will tell the container, delete it. OK. And it will also delete other resources, like maybe if we allocated networks, created networks or volumes or whatever. But so why do it like this and not inside the JVM? Because the initial version of it was a thread, a resource repo thread inside the JVM. Someone has an idea why it's, and it would, like on JVM shutdown, automatically also kill the container. So it would kill them after the tests are done, and also if the JVM would shut down for whatever reason. So anyone has an idea why this is not a perfect idea to do this cleanup from the JVM? So what would happen, how you would register this behavior, like on JVM shutdown, do something, it's adding a shutdown hook in the JVM. But this shutdown hook doesn't always get executed, and it also says there in the documentation, when doesn't it get executed? In case you are sending a SIG kill to the JVM. So normally, if you stop it, it would send a SIG term, it gets a shutdown hook, all is nice. But if you're sending a SIG kill, it will just kill the process, basically, and the shutdown hooks are not run. When would you send a SIG kill? And there are like normal use cases when this could happen. For example, if you're debugging an application from IntelliJ, for example, you're at a breakpoint, and then you're stopping there, and then it takes a couple of seconds. In this couple of seconds, the stop button becomes a skull, and if you then click the skull, it sends a SIG kill, then the JVM is gone, but still the containers are lingering around there. And it also will happen normally in CI environments. If you're canceling CI jobs, they will also just kill the CI process, normally. And then you have this zombie containers running around. You don't want this, of course. But now we don't have, and even if I would do the SIG kill, it would not happen. Why doesn't it happen? So we removed it from the JVM in the sidecar container. It's a small Go binary that's running in a container, and the JVM is sending kind of a heartbeat to this Ryuk container, and once the JVM stops sending this heartbeat, because it might have been killed, Ryuk container knows, okay, the tests don't run anymore, we can remove the container, then it kills and removes the container as well. And yeah, this is working very nicely since then. Okay, this, of course, super simple example with a Postgres. We now have a more complex example for a Kafka. So here we will have the special offer notifier that is just sending records into a Kafka topic. And again, we are defining here a special container, Kafka container. It's already brought to you by test containers. We have a special Kafka module. And what we are doing, we are creating our special offer notifier object. Again, we're doing this kind of dependency injection, getting the actual bootstrap server's URL from the Kafka container after it has been started. We are looking into the implementation, and here we are seeing something very similar to the example we've seen with the Jdbc container. We are getting the container IP address and the map port to construct the URL. Okay, and then we are creating a consumer because we want to test that if we send a message in there, that it can be pulled from the topic. A lot of stuff coming up. Okay. So here we see, of course, the Kafka we would have expected, and Ryuk again, and also another sidecar container. This sidecar container is kind of special for the Kafka container implementation we have, because if you are running Kafka in a container, it gets kind of complicated. So Kafka inside a container is not a problem, but Kafka uses Zookeeper. And Zookeeper inside a container is not so nice, because Zookeeper wants to know the port he will be reachable from on the outside before it starts, so at startup time. And once it started, you can't say on which port it's actually reachable. So there is nothing support, basically. And in the case of test containers, what's the problem? When I start the Zookeeper container, I don't know under which port it will be reachable for my application, because I'm doing a dynamic port binding. Yeah, and so it didn't work with dynamic port binding. Zookeeper was not made for this. And then we added this sidecar container, which is in the same Docker network than the Zookeeper, and it just translates the TCP stuff, basically, like a transparent proxy in this case. So the Zookeeper can still listen on his static port, but inside the Docker network only. And yeah, the tests worked. Again, it takes like 15 seconds here, but I think 15 seconds for bootstrapping a whole Kafka, including a Zookeeper, it's okay. Yeah, we can live with this. And of course, we can think about testing strategies where we would do it just once for our test suite, because we have a strategy for the actual test pollution, like using different topics or cleaning the topics or whatever. Then we have this overhead. Let's say it's maybe 10 seconds overhead. We have it once for our test suite. Then it's okay. All right, so these are the basic Java examples, and like how I would integrate a vanilla Java application with test containers. And now I would go to some Spring Boot examples. Are there some questions until here? Okay. Who here is a Spring or Spring Boot user? Okay, and who is in the Java EE camp? Oh, one. Okay, so who didn't raise their hand now while I asked those two questions?
They're just plain Java users.
Yeah, just plain Java users. So, but you know, or who doesn't know Spring Boot?
You mean
Like just doesn't?
heard of it? Or?
Yes, don't heard. You don't know what it's used for.
No, I know.
Yeah, so it's like Spring is a dependency injection version of control container, and like the ecosystem around it is for, yeah, you can use it, for example, for web applications. Let's say it's a web framework. It's not this, it's much more, but let's, for the sake of this example, say it's a web framework, Java web framework. All right, so we are having a very similar example here. We are having, again, a book class. Now we have a Spring Data repository, book repository. Then we have a customer class, also super stupid. And just because I wanted it to be more fun, I put it in a Mongo repository. So we already have two integrations here, one against our relational database, one against a NoSQL database, Mongo in this case. And yeah, this is the application. So now I have a lot of different ways how to do this with Spring. Because what's the problem with Spring, or the way Spring test integration works? Normally, so you have to think about the Spring context lifecycle in relation to your test lifecycle, basically. If you are doing the simple Spring test with @spring-boot-test annotated, it will normally spin up the Spring context before you get into your test code. But we've seen before that we only know the actual URLs or whatever where our containers are reachable after they have started, so after the life cycle of the extensions or whatever have been run through. So we need to find this intersection point where we can start the containers before we start the Spring context, and then inject the actual configuration we need for our test into our Spring context before it's initialized, because it won't correctly initialize, for example, if it can't build the data source for the JPA test. And we have some different ways to do it. But first, I show a really cute example that only works for Jdbc testing. We have a feature in test containers for Jdbc testing and Jdbc containers, which is called, I don't know how it's called, but what you can do is you can use a special test containers Jdbc driver. And by this, I just mean a special Jdbc URL, basically. We can see it here. This you could use and put in your application properties YAML in the tests statically. And what we see here, it looks like a normal Jdbc Postgres URL, but we have this TC in there for test containers. So we are providing our own database driver proxy, which I'm defining here, driver class name. It's a container database driver. And what this proxy will do, once a connection is requested to this Jdbc URL, it will spin up the container dynamically, and then it will proxy it to there, the actual connection. So you can get going with using test containers for your normal applications where you're using Jdbc URLs, just by using this kind of Jdbc URL. And here I'm using Postgres, but you could also say MySQL or Oracle or whatever, and here's the image name. And yeah, basically that's the only integration point to test containers you're having. What I'm doing here is, like, it doesn't matter where you do it here. I'm doing a system set property. Like, it would be the same if I would put it in the application properties or application YAML. I'm just using the Spring configuration resolving here. And I'm just having an abstract base class. That's like a nice pattern to have maybe in Spring, an abstract base class where you do this wiring of your containers to the environment and then have the actual test extend this base class. So if we look at the actual class, we see we don't do anything here, test containers related. And hopefully it will just work. Mm-hmm. We will actually see here, yeah. In the next example. Okay, yeah, here, those exceptions don't matter actually. It's some mismatch of the driver version, I'm not sure. But here we see the Postgres is starting. Yeah, and then everything works. And it's restarting all the time because I was kind of stupid and annotated this with @dirty's context. Yeah, that makes it, of course, more slow. But yeah, so we just see we don't have to do any test containers interaction here. No objects, no classes we have to instantiate whatsoever. So this is one way. Another way would be to have containers as beans. I think it's kind of cute, because if you do it like this, you can make sure that the starting of the container is in the correct part of your Spring context lifecycle. So here we're having like a bigger test where we see on the one hand it's the same stuff we had before, like the book repository stuff, and here I added more test cases to this test class where we would interact with the Mongo database. And now I'm defining here a custom test configuration. So this is all Spring specific stuff. If you're not using Spring and are not interested in how we do it in Spring, you don't have to listen. I don't know, check Twitter. But it's interesting and important to know for those who use Spring, because else it's kind of complicated and cumbersome if you don't know the solutions. And here in the test configuration, I'm just starting the actual container. So here we have a Postgres container and a Mongo container. And here we see it's a generic container, so we don't have anything special. Mongo works just out of the box in a container, kind of. And here in those methods, that creates the beans which represent the interface to those containers in the Spring world. Like we have a data source that would interface with the Postgres. We have a Mongo client that would interface with the container. And here we start the container and then construct our data source or Mongo client according to the actual addresses of our containers. So this works kind of nice. So then we are at the right point in the application lifecycle. I can just run it. And then we can, like in the destroy of the configuration, stop the containers by hand. So I'm just doing start and stop here by hand. I'm not doing, not using the test framework integrations of test containers. But also something to keep in mind, you generally don't really have to use the test integrations. They give some syntactic sugar, but you always can also just do start and stop, and it works really fine. And that was just quite fast, I think, 18 seconds for tests against the Mongo and the Postgres. Of course, most of the time was starting up the Spring context and the actual containers. There's one problem with this approach, and that is that I'm kind of overshadowing my actual production configuration code here, because I'm creating my own data source, and there might be some weird parameters set in the data source creation in my real production code, so it's not perfect here. I'm not sure how I really like this approach in practice. Yeah. Yeah, but then still it might be the same data source definition. I really don't want this. There might be a way, I haven't tried this out, there might be a way to inject the data source as a dependency in the method again and then modify the data source, but I haven't really worked with modifying a data source after it has been created by Spring Boot auto-configuration, so a bit cumbersome. We have a different pattern here, and it's kind of the most simple one in the context of Spring and the fastest one, but it has some negative aspects also to it. We call it singleton, whoopsie, abstract singleton, yes. We call it the test container singleton pattern internally. And what do I want to do here is I just want to start my containers once for my whole test suite and then reuse the containers all the time. This makes things, of course, much faster. But on the other hand, I myself have to take care of test pollution, which is maybe okay. Maybe starting our infrastructure to avoid test pollution, it's just too expensive. Maybe we should find a way on a more logical level, like truncating tables or whatever. So what do I do here? I have an abstract base class. I have a static initializer block here. I'm defining the containers I want to use, a Postgres container, my Mongo container. Then I'm starting them here. In this case, like Java 8 stream, and then do a parallel start. That's kind of a good pattern for starting multiple containers at once. And then I'm setting the properties here, the Spring properties, like you would set from environment variables or an application YAML. I just do it here by system set property, and then they are set inside the JVM, and then Spring will automatically use them to configure the context accordingly. And yeah, that's it. I'm not stopping them, I'm not cleaning up here, because I assume they are running for the whole lifetime of the JVM and the test, so they are kind of, by definition, implicitly bound to the life cycle of the JVM, but it's okay for this use case. And yeah, then if I want to use them, I just extend this base class in all my tests that want to interact with them.
Where do you run your flyway scripts on this setup?
Where would I run my flyway script? So if you have the flyway integration in Spring Boot, they would automatically be run when the Spring context gets initialized, and then it's fine in the life cycle. Yeah. So yeah, that's not much faster. Well, it actually is faster. Why is it faster? Because I'm starting the container in parallel now. Nice. So yeah, I think this is one of the best patterns for doing it with Spring and Spring Boot, but it needs a bit more of discipline to not do test pollution. But we have this in other test cases after all the same. So yeah, I think it's a trade-off that's worth it, and it's something I want to share with like the possible test containers users, that they are aware of this pattern. Yeah, any questions so far?
There is this dirty context, I guess.
Oh yeah, I just did this here because I have these other tests in the example that do kind of get stuff with the system set properties. Normally, if you...
It's the container, if it exists, is it running?
Dirty context is from Spring. It's a Spring Boot test annotation, or Spring test annotation. Let's see where it's from. Spring Framework test annotation, yes. It reinitializes the Spring context, yeah. And I do it because I'm doing the system set property stuff. But if you would follow the singleton container approach, you would normally not need to use this, for at least regarding the interactions with the containers. By the way, I'm not sure if I mentioned this, but it's a free and open source project, Test Containers, like MIT license. It's available on GitHub. Everyone can use it. Everyone can contribute it. Yeah, that's just by the way. Any questions? Any other questions so far?
Are these sample codes available to us?
Yes, I will post the slides and the examples on Twitter, and then the Jug can retweet. All righty. Oh, we have some more time. Okay, next step. We did kind of white box integration testing so far. What I want to look into now is more like black box testing, black box acceptance test testing maybe. For this we want to use Docker Compose. Who here doesn't know Docker Compose? Yeah. Yes, so Docker Compose is again a tool from the Docker ecosystem, also made from Docker, and we can use it to run multiple containers which together define kind of a system. So it's convenient for smaller microservice setups maybe. And the example we want to look at now is this microservice application. So for those of you who have seen the DockerCon keynotes 2 years ago, they used this kind of application for most of the demos. It's a voting app. We're having one front end in Python, another front end where you can vote about stuff, another front end written in JavaScript where you can see the results of the vote. Then we have two different persistence layers. One is a Redis, another Postgres, and then we have this background worker container written in .NET that will like persist the stuff written into the Redis in our nice relational database. And let's look at this application. Another thing you're kind of seeing here is that we can use test containers in our Java testing frameworks, not only for testing Java applications, Java containers, Java images. We can do like really polyglot testing scenarios here. So wait, I have to open the project. I want to show you how it looks first. Okay, did it open? Yes. Maybe before we look at it, let's look at it first. Okay. So I'm starting it here. Whoop, whoop, whoop. Yeah, probably it's running now. Okay. So this is a voting front end. Here we can vote between two things. We vote for Groovy, of course. Who here uses Kotlin? Who here has tried out Kotlin? Yeah, we also tried it out. It's kind of okay. Yeah, it's not bad, but Groovy is a bit cooler. Yeah, and here we see the results, how it should be. All right. So this is this, and those 5 services. How are they actually described in this Docker Compose? So you use Docker Compose by describing how those services relate to each other in a Docker Compose YAML file. And it looks like this. So you have the different services, the vote front end, the Redis, worker, DB, whatever. And then you have here the image they are using. And like everything you also have normally on the Docker command line, just here as a configuration in a YAML file. And we also have, no, here we don't see it. But we will see it in the actual Docker Compose, probably. Yes. We also have networks, so we can define networks in the Docker Compose, and then we can put containers, services on the same networks. Like here we have this front-end network, back-end network, and the nice thing is that services, containers that reside inside the same Docker network can address each other using their container names by basically using DNS. So that's super cool. So yeah, now what we've just seen, the small demo, we now want to exceptions test this, UI test this. What will we use for this? We can use a nice library called Jeb. We can, of course, also use the Selenium directly, but Jeb is kind of nicer, I think, and it very nicely integrates into Spock. But I think you also can use this with normal JUnit. But probably it always depends on Groovy there. So what is Jeb? Jeb is like another abstraction built on top of Selenium Webdriver. It's kind of its own DSL for writing Selenium tests. And you have very cool stuff there, like pages. You are modeling the pages of your application front end, like the views as real page objects in Jeb, and then you just say, okay, go to this page. And then in this page, you have these checks that make sure that it blocks until the page has actually rendered, like you can check for this element to be reloaded, whatever. So it's very, very convenient and very good for writing real stable Selenium tests that are very readable. And then you have a jQuery-like API to access elements from the DOM and interact with them, like click on them or just see what's in the content, attributes, whatever. So we will use this for our test. And let's check. All right. So we are having here, again, a special test containers class. It's Docker Compose container. And here we can just specify the Docker Compose we want to use. And what it will do in the end, it will do something like Docker Compose up for us, but also implement stuff like the wait strategies and so on. And here I'm saying with local compose true, which means it will use my locally installed Docker Compose version. By default, it will not use the locally installed Docker Compose, but instead use spawn a container which contains Docker Compose and then do some weird mounting stuff to get it up and running and proxy everything. But it's more complicated, and I think we will deprecate it in the future. So I generally recommend just use local compose if it's possible in your environment. So this we will use for getting the voting app we've seen up and running. And then we have another special test container. It's the browser WebDriver container. This is a container which contains Selenium WebDriver and an actual browser. In this case, Chrome, since I say with desired capabilities Chrome. And it will render, like it will have an X server inside, and it will render everything inside a dummy frame buffer, kind of. So that it runs kind of headless, but not really, since it still has this frame buffer where it's rendering stuff to. And here we have another nice thing. We can say with recording mode. Here I say recording mode, record all, which means that we will create a video recording of all tests that are run, of what's happening in the browser. Quite nice. And we will see this, and I will, to show you that I'm not faking, I will delete the old one I'm still having here. So, and what are we doing here now? Again, I'm not using any test containers test framework integration. I'm starting the containers by hand. I'm first starting the Docker Compose. And what I do now is kind of a hack, and I don't want to explain it in detail, but you can check the source code later if you're interested in. But what I want to achieve is I want to put the Chrome browser container onto the same network as the front ends I want to interact with. Why do I want to do it? Because I want to statically address those containers over their DNS, over their name. And then I can code the URL statically. And that's quite convenient. And there I don't have to get any map port or whatever. So I'm having here this kind of hack to find the IDs of the networks that have been created for the Docker Compose front-end servers. And then I'm using this with network method from test containers on the Chrome to kind of attach it to this network. So the API here is not really that user-friendly, but I hope we will improve it soon. And yeah, then I can start it afterwards. If I would have defined the Chrome inside the Docker Compose, I would have not had this object as the Chrome container as an object in my test class, so that also would not have been a solution. And yeah, here, this browser driver setting, this is something JEP specific. It's just setting it JEP to use the Webdriver we get from this Chrome container. And again, I've set here stepwise, so all tests will be run in the order they have been defined. I will first visit the road website. Here we see I can just use the container name to visit it. The sleeps here, I mainly put them in so we can see something in the video, else it's much too fast. But you don't want sleeps in your test, of course. That's like, guarantees of race conditions normally. So we first go to the vote side. Initially, both texts, we just look that the buttons have the correct text. Then we go to the result page. Initially, both should have result 50%. And yes, a clever observer might see that it's using cats and dogs here, so you might imagine what was the original content of the text. And then we go again on the vote side. We are clicking on one button. We then go to the result page, and then we see that cats, in this case it would have been Groovy, has the value 100%. So let's see. Maybe it's trying to pull the images, that's why it takes some time. Ah, yeah, there they come. Okay, we see all the Docker Compose things. Now we see here Selenium. Now we see here VNC Recorder. That's another sidecar container we are starting. We are attaching it to the Selenium, and then we are recording the actual session via VNC, so we can save it as a video. And yes, everything green. And now we see here we have a new file here. Whoop. Whoop, whoop, whoop. Show in Dolphin, yes. So, and here we see it works. And yeah, I don't know, for those of you who need to maintain some Selenium somewhere or Selenium cluster and know how kind of cumbersome and high maintenance this stuff is, I think it's pretty cool that we can just define it as part of our tests and give it to all developers. And yes, I promise you that if you check out this project and just do the Gradle build or run the test from the IDE, that it will work for you, I hope. So everyone who came to me after the talk afterwards said that it worked for him. So it should work for you. What else I can do? Another cool thing I want to show is if I'm leaving the presentation mode here. This is the wrong one. Here, yes. So I'm now putting a breakpoint after the container has started, the browser has started. Because what I want to show is that since it exposes its X server via VNC, we can also remotely connect into this running container with the browser and do whatever we want. For example, so now we're here, I can now get, I will get chrome.vnc address. Yes, there it is. So this is a connect. This is the. This is where it's reachable, and now I'm using a VNC client to connect to it. See if I correctly copy paste it. Bam. And now I'm in the browser inside the container, and I can do whatever I want. If I go to, where was it running? Vote. Yes, it works. I can now click stuff here, and it works. But I can, and that's like kind of a cool thing, I can, of course, more tools, open my developer tools and see what's actually happening there, if I need to debug a test or whatever. So it's like quite convenient, and it's not always that easily achievable if your Selenium tests are always just running in your CI environment or whatever. Yeah, so that's that. Okay, any questions so far? All right. So how much more energy do you have? Shall I go on over this topic, like running continuous integration inside your containers, or do you want me to move to the end?
Let's take a break.
Ah, no, no breaks. It's not that long anymore. So, just, okay. Okay, let's go inside. So what now happens if my CI environment is already running inside a container, like, for example, something like GitLab CI, or I'm having Jenkins and my workers are running inside containers? Does it become complicated to also use containers from inside my containers? The answer is yes and no. So there are different approaches how we can solve this problem, and they all work with test containers. So one way to do it is using Docker in Docker. We call it dint normally, and that's also the way how GitLab CI kind of officially documents it. And what does it mean? This means you're running a Docker daemon inside your Docker container, like a real Docker daemon. And every container you are running is then a child of the process inside the container in the end. And it kind of works, interestingly, but the people from Docker itself, they like made blog posts and tweeted on Twitter, and they discourage this behavior. So they say, okay, you can do it, but actually we as the developers from Docker, we are not 100% sure what might happen in these cases. But I don't know, many people do it like this, and it works for them, but you have to keep some things in mind. When you're running inside the container, you normally don't have images cached in there. Depends on the image you're running in, of course. But for this test container stuff, you of course need all these images you want to integration test against. We now use Selenium, we use Postgres, we use Kafka, all kind of stuff. So you either need to bake this into the images, in the build images, then they become quite big, but then this works. Or you might think about like, oh, maybe I can just share them by mounting a cache, and then they all have the same cache of image cache, and this is definitely not a good idea. So there, the Docker people clearly says the Docker daemon is not made for concurrent usage, and the Docker data structures are not made for concurrent usage. I think the Docker daemon is basically a single-threaded model still, and like you are corrupting your layers there, like the layers of the images you're pulling. So that's not really a good idea. So if you need the cache, you need to bake it into the image, or just live with the performance overhead, like the slowness of pulling the images for every CI run. But it's really slow because you are pulling it into your copy on write file system into the container, which makes it even slower. Sometimes it might be like the best way to do things, but generally I would personally not recommend it. What I would personally recommend, on the other hand, is another pattern. And Roland Huss, who also made the Docker Maven plugin, calls it the Docker wormhole pattern, and it's a cool name for it at least. And what we are doing here is we are mounting the Docker socket into our build containers. So we are having here our actual Docker engine running on a host. We are now spawning a build container where we will run the build. There's a Docker client installed. And then we do a normal volume mount from the host of the Docker socket. That's super easy on Unix, of course, because it's simply a file in Unix, the socket. And what happens then, if the Docker client inside the container speaks with its socket, it actually speaks with the engine of the host, which means all spawn containers will not be children containers, but instead sibling containers, which is okay normally. So you just have to know this, because what will happen if you try to mount files? So if you're running here, you say Docker client, Docker run, and then mount a file like -v current working dir to work dir in container. It will then mount the dir directory from the host. And that's never what you want normally. So the normal CI stuff happens like this. You're running inside the, so the CI spawns the container, it checks out the source code inside the container, and then if you maybe want to mount some stuff from test containers, we have these functions also, like mount some stuff from your repository into the container in your CI environment. It will not work because it will mount everything from the host. And there's the, I think, best approach is don't do file mounting or volume mounting there, like bind mounting, it's called, yeah? Don't do bind mounting. Instead, what very good works to get data from inside the container into the sibling containers is copying. If you run a Docker copy, it will work because it will simply send the data stream. And this is also supported in test containers, like just say copy file to container. You can copy a complete directory there. And I would recommend this. Yeah, so if you're starting this whole Docker in Docker journey or running your CI in Docker, it's very important that you kind of know what happens and where the containers are standing in relation to each other, or else it becomes super confusing when you move files or artifacts to somewhere else. So I think it's good to have heard about these problems if you haven't lived through them, experienced them as, yourself already. Okay, I think we kind of finished everything I wanted to talk about. Let's have a small look into the future, to the future of test containers and testing and Docker integration maybe. So we are now with test containers on version 1.10.1, and we plan at one point to release the test containers version 2, which will have basically a complete breaking public API change. So we plan on changing the API either to a more builder-like approach, or we experiment with some other ways with some like anonymous functions for initializing the containers, because currently we are working quite a lot with generics. So all the methods from the, so I can have a quick look in the source code. If we look, not in this, let's go here. If we look, no, share, okay, let's just look in Postgres container. We see this kind of strange construct, this is self-typing generic stuff. It's because we are having this fluent builder-like setters to say like with exposed ports, with waiting strategy, like chaining them together and to make these methods of the generic containers base class. So we see this extends here Jdbc base container, database container, and this on the other hand extends generic container. So to make this fluent builder like setters work, we need this generic self-typing, and Kotlin doesn't like it. And like Kotlin basically breaks with this, the Kotlin compiler, the Kotlin type checker, and so we try to come up with another solution there. And also because it's complicated and people don't really understand this. Yeah, it's not too nice and not something you usually see. So this will happen. Then another thing we've seen is that people started using test containers not only for test-related stuff, but also as kind of just a Docker library as an object-oriented abstraction of Docker containers, because the existing Docker libraries in Java are not that convenient to use. Like we are ourselves using the Docker Java library, which is just basically a translation of the Docker REST API. So it's okay, it works for the use case, but it's a REST API. It's not an object-oriented programming metaphor. And we want to provide this. It's kind of there already. So you can use now test containers in an object-oriented way for the containers, but we want to get it out of the test framework specific stuff. So currently, at least from a build side, test containers is interwoven with JUnit 4. So you will automatically get JUnit 4 as a dependency if you are including test containers. And we want to change it and make the actual core test framework agnostic, and then have the implementations of the other test frameworks as modules, what we already did for Spock and JUnit 5 integration. Then we are welcoming new languages to the test containers family. We now have .NET, a Go port, a Rust port, a JavaScript port, even a Python port. They are complete rewrites, kind of. So we don't have any shared code, but we try to align our concepts and programming models with each other. So they kind of work how you would expect it. They are also on GitHub in the test containers group, the test containers organization. They're kind of alpha, very, very alpha, so they don't have the same feature sets than test containers Java. The .NET version is something you might be able to use in real work environments, I would say, but very alpha still. Then we are working for Windows containers on Windows support. So do we even have Windows users here? Yeah. So it's kind of interesting in Windows. So the Windows kernel also has container support, but not for the normal Docker Linux containers, only for Windows containers. And the way Docker on Windows works is through a hex, through a virtual machine. But like you can also run containers on Windows, on the Windows kernel, which then has this Windows user space stuff. And it would be kind of nice to start and stop them with, or instrument them with test containers, because they are using the same API. You can instrument them, interact with them with a Docker CLI. Yeah, but the problem right now is that you can't run, at least in the normal consumer builds, you can't run Windows container engine in a hybrid mode. So it will support the Windows containers, but still supports this hacky way of running Linux containers in the virtual machine. So you have to decide. And since we are using this Linux containers, sidecar containers and test containers, like the VNC recorder we've seen, or this Rio container, it will not work currently with Windows containers. If you disable them, so I just like disabled the code branches and tried out if I can start and stop Windows containers, it would work in theory once we get the hybrid mode working there. And yeah, something I will not actively work on, but I hope JetBrains and co will try to include, is having full IDE support to transparently run and build all my stuff I do from the container, from the IDE inside a container. So what I've shown when we just do a run of a test, it of course runs it locally, but I wanted to just in the background start a container, do everything in the container. Why do I want this? Because once this would be transparently implemented, I'm running my tests inside a container, which I then could attach to a Docker network. Then I can interact with all my external dependencies using DNS. Then I don't need this dynamic mapping stuff anymore. Would be quite nice. And I think it's very much possible because PyCharm supports exactly this. So in PyCharm, you can configure a Python interpreter to be an actual Docker image or Docker container, I think, and then everything you're doing in the IDE is transparently done in the container. Super cool, but the other IDEs from JetBrains don't have it, and also the other Java IDEs like NetBeans, Eclipse. Not as far as I know. All right, yes, these are the links, but I will share the slides on Twitter, and then you can just go there and, and follow the links if you want. All the examples are on GitHub. You can just check them out, and they should work out of the box if you have Docker installed. Yes. leaving some seconds for pictures. And, oh yeah, not important. And okay, so that's it. Here we see like the Duke can be a good friend with like the container and the Docker ecosystem and the friendly Docker mascots. And yeah, I hope you liked it. You maybe learned something, or you got inspired to change something in your daily life. And I'm open for questions. Or not.
Are there any plans for supporting Kubernetes, much like Docker Compose?
I get this question nearly every time. Yes and no. So I'm planning, or we're planning to at least try out if it would easily be if we could easily support Docker Swarm using the Docker Compose stuff we already have, since you can now switch the Docker orchestrator transparently to use either Swarm or Kubernetes, we might be able to have automatic support of Kubernetes once we have support of Docker Swarm. That's like something I might need to do in a spike at a weekend in a hackathon somehow. Yeah. So maybe yes. I think people really want this, but I don't know. Why do you want this?
Because it might be more realistic, more production-like environment to run on Kubernetes clusters, rather than, because you might already have prepared your deployment YAMLs for Kubernetes, then you have to go to prepare Docker Compose files as well. That's an extra work you don't want to do. That might be one of the reasons.
Yeah. So, but then more for the bigger, like acceptance test, end-to-end test scenarios. Yeah. Yeah. Thank you. Yes. So, by the way, I have some stickers here, if you want.
Small gifts from Jack Istanbul.
Cool, thanks. Yeah, so if anyone wants test container stickers, here are some. Now I check the gift. Cute. Yes, it's too cute.